Hello, and welcome to the third day of our unit on sequences and series. Today we're going to look at some new notation. We call it sigma notation, or sometimes they say summation notation. Mathematicians have a shorthand way of writing out this series, 6, 10, 14, all the way up to 26. What they do is they find this equation, which is 6 plus 4n minus 1. That'll give us our t sub n. And what they do is they plug it, they put it on the right-hand side after this sigma. This is a Greek letter, sigma. And they say we go from n equals 1, which is the first term, to n equals 6, which is the last term, because there's 1, 2, 3, 4, 5, 6. So when it has this, what it's looking for is an actual answer. So the answer of this would be 6 plus 10 plus 14 plus 18 plus 22 plus 26, which is 96. So that's the sum of all those digits. It is 96. We already did this one, 96. So let's look at this one. Sum from the first to the 8th. So we're going to have the first digit being 6 plus 10 plus blah, 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 all the way up to t sub 8. Now I would just find t sub 8. T sub 8 is 6 plus 4 times 8 minus 1, which is 7, which is 28 plus 6, which is 34. This is an arithmetic series, so we can add this up. S sub 8 is going to be our n, which is 8, times our first term, which is 6, plus our last term, which is 34, all divided by 2. So this would be 40. 8 times 40 divided by 2. This is 320 divided by 2, or 160. So the sum of the first 8 terms of this equation is going to be 160. Let's try this one. Our first term is 10, and it keeps going down by 7. So it'll be 3 and so on. So if I want to go to my 5th term, I would do first find t sub 5, which would be 10 minus 7 times 5 minus 1, which is 4, or 10 minus 28, which is negative 18. So to find the sum of that, s of 5, we'd take the terms, our n, which is 5, take our first term plus our last term, and divide it all by 2. So this would be 5 times, this would be a negative 8 divided by 2, which is negative 40 over 2, which is negative 20. So the sum of my first 5 terms will be negative 20. Let's try this one. The first term would be 4. The second term would be 8. Third term, we plug in 3, would be 12. Fourth term would be 16. Fifth term would be 20. So this is an arithmetic sequence. Now, this one, since we could have done this with the last problem, since this number is low, we could just add these up. 4 plus 8 plus 12 plus 16 plus 20. And I got 60. I don't know why that's so tough for me. There's 60. Or we could do s of 5 is equal to 5 times my first term plus my last term divided by 2, or 5 times 24 over 2, which is the same thing as 5 times 12, which is 60. So both methods work just fine. Let's try this one. 1 squared is 1, plus 3 is 4, plus 2 2 squared is 4, plus 3 is 7. 3 squared is 9, plus 3 is 12. 4 squared is 16, plus 3 is 19. 5 squared is 25, plus 3 is 28. 6 squared is 36, plus 3 is 39. Now this isn't arithmetic, nor is it geometric. This is quadratic. So the only good method we have for summing these up right now is just adding each of them together. And I get a grand total of 109. Now let's try this one. 2 to the first is 2, plus 2 to the second, which is 4, plus 2 to the third, which is 8, plus 2 to the fourth, which is 16. If I add that up, 2 plus 4 plus 8 plus 16, I get 30. Or, since I'm multiplying by 2 each time, this is a geometric series. So the sum of a geometric series, sum of the first 4 terms, we take our first term, which is 2, times 1 minus our r, which is 2 again, to the nth power, which is 4th, all over 1 minus my r, which is 2. So this is 2 times 1 minus 2 to the 4th is 16, all over 1 minus 2, which is negative 1. This would be negative 15, so negative 15 times 2 is negative 30, divided by negative 1, which would just give us a positive 30. So both methods give us the same answer. If n only goes up to 4, I think this first method would be the easiest. Let's try this one. Plug in a 1. 1 cubed times 2 is 2 minus 1, 1, plus 2 cubed 8 times 2 is 16, minus 1 is 15. 3 cubed is 27. 27 times 2 is 54, minus 1 is 53. 4 cubed is 64. 64 times 2 is 128, minus 1 is 127. Plug in a 5. 5 cubed is 125. Multiply by 2, you get 250. Subtract 1, and you get 249. So now, this isn't arithmetic. We're not multiplying by 15 each time, so it's not geometric. So all I can do is add up these digits. Which I get 445. All right, now since this is going to 15, to add those all up and find them all out would be a lot more annoying. So let's just use our formula. Hopefully you can recognize this as an arithmetic series. If you can't recognize that, you can do out the first few terms and see if it's going up by addition or multiplication. So our formula for arithmetic, we take our n times our first term plus our last term all over 2. So our n here is 15 because there's 15 terms. Our first term is that number, which is 5, plus our last term would be if we plug 15 in. So let's find t sub 15. It would be 5 plus 2 times 15 minus 1, which is 14. So that's 5 plus 28. I think that's 33. Divide that by 2. So we have 15 times 38 all over 2. And I get 285. So S of 15 is 285. Let's try this one. To the 10th, that's quite a bit. This, hopefully you can tell, is a geometric series. You have your first term times your r to the n minus 1. So first we have to write the formula, which is going to be your first term times 1 minus r to the n all over 1 minus r. So our first term is 6 times 1 minus our r is 1/2 to the n power, which is 10, all over 1 minus our r, which is 1/2. Now, first I take 1/2 to the 10th power. So 0.5 to the 10th power, that's an extremely small number, very close to 0. If I take 1 minus that number, I'll have 0.999. So this would be 6 times 0.999, all over 1 minus 1/2, which is 1/2. So I'll multiply that number times 6, divided by 0.5, and I have 11.988. So in this series, the sum of the first 10 terms is 11.988. Try this one. The sum of the first 9 terms, our first term will be 27 times 1 minus our r is negative 2/3 to the 9th, all over 1 minus negative 2/3. So this becomes a plus. Negative 2/3 to the 9th becomes negative 0.026. 1 plus 2/3, 3/3 plus, that would be what, 5/3? So this goes to minus a negative would be a plus, 1.026 all over 5/3. Now I just type this into your calculator. And I get 16.62. All right. Try this one on your own. Hopefully you can see that this is arithmetic. So S of 52 is going to be our n, which is 52, times my first term plus my last term, which is going to be 46. I should write t sub 52 is 46 plus 3/4 of 52 minus 1, which is 51. So 51 times 3 divided by 4 is 38.25. Add 46 to that, and I have my t sub 52 to be 84.25. That's divided by 2. So now I just do the math. And I get 3,386.5. Notice if we wanted to do this by writing out the terms, it would take quite a while. All right, now we want to use sigma notation to represent these series. This first one, we go from n equals 1 to n equals 5, because there's 5 terms. This is geometric. It starts at 81, and we're multiplying 1/3 each time. So, and then we put that to the n minus 1, because this is the explicit form. All right, for this next part, we have, there's 1, 2, 3, 4, 5, 6, 7, 8 terms. So we're going to go from n equals 1 to 8. Now on this one we have 1, 4, 5, or 1, 4, 9. So this is going up by 3, going up by 5. So it's not arithmetic. If I multiply by 4, I don't multiply by 4 to get the next term, so it's not geometric. So let's look and see if we can find any other pattern. 1, 4, 9, 16, 25. These are all square numbers. So if I take my n value and square it, I will get each of those numbers. All right, try these on your own. When you're ready, start up the video. We can count up to 7. So this is n equals 1 to n equals 7. This is arithmetic because we're going down 5 each time. So it would be 17, not plus, but minus 5 times n minus 1. And that would work. This next one confuses a lot of people because it goes from positive to negative to positive to negative, positive to negative. But really all you're doing is multiplying by a -3 each time. So that's my r value. My initial value is 4. I'm multiplying by -3. And I'm going from my first term to my 1, 2, 3, 4, 5, 6, 7, 8. To my 8th term. All right. I hope this makes sense. Good luck on this homework.